We're going to be factoring by the greatest common factor, and we know how to find the greatest common factor, and now we're going to apply that to polynomials. Form when it's written as a product of monomials and polynomials that cannot be factored further. That sounds complicated, but all that means is if I have an example like this, 2 times 3x minus 4x, this is not fully factored because I've got a term that is common to both of these. I've got an x that's inside these parentheses that is common to both terms. So this is not fully factored. So let's look at what we do to fully factor two terms. So I've got this term here. Remember, my 9y squared could be factored into 3 times y times y. And my 45y can be factored as 3 times 5 times y. I've got a 3 that's common to both, another 3 that's common to both, and a y that's common to both. So I've got a 3 times y that's common in both of those, or a 9y. Okay, so 9y is common to both of these terms, so I can take that 9y out. And when I take that 9y out, remember what we did in the worksheet today, I still need a y to multiply by in order to get 9y squared. And a 5 will get me 45y. So now this is fully factored. Notice there are no common factors inside my parentheses. Let's try another example. I'm going to go through this a little more quickly. So I'm going to find common factors of 36 and 24. Well, the greatest common factor of the coefficients is going to be a 12. And notice I have no variable here behind the 24, so I can't take a d out. So all I've got to take out that's common to both of these terms is a 12. Then I need to multiply that by 3d cubed, and I need to multiply the 12 by 2 to get to the 24. So inside the parentheses, I have no common factors. And if I were to distribute this back out, I would have exactly this polynomial here. Trying it one more time, common to all three of these is an 11. And notice I've got at least a d here. So I would need 3d to the 4th. Remember my exponent rules, that's 1 and 4 is 5, so there's my 5, plus 2d, so that's 22d squared, plus I've already taken my 11d out, so I'm going to have a 1 here to show me that that 11d is what's being represented here. I've got one 11d that's left over that was common to all three. Okay. So the other thing we can do, though, is we can factor out a negative sign. Notice this term is negative and this term is negative. So not only do I have a 5 that's common to both of them and a w squared that's common to both of them, but I also have a negative that's common to both of them. Now remember that it's going to mess up your signs, though. So when I take that negative 5w squared out, I need a positive 3 to multiply by to be my same negative 15w squared that was up here. And I also need a positive 2w to multiply by negative 5w squared to give me negative 10w cubed. So this is completely factored. So try this one on your own with negatives. Okay, hopefully that worked for you. All right, sometimes the greatest common factor of a term is actually a binomial. So notice I've got x minus 3 here and I've got an x minus 3 here. So this is common to both of these terms. So my x minus 3 is now detached from these polynomials as the greatest common factor. What I have left is a 7 right here and a negative 2x right here, because those were what was left over when I took the greatest common factor out. Here are some other examples. I'm going to run through one with you, and you can do the last one on your own. So I've got an s plus 6 common to both of them, and what's left is a 4s minus 5. Easy enough. I've got a 2x plus 3 common to both of them, and a 7x plus, there's nothing here. So remember, the placeholder is 1, because I really do have one 2x plus 3. Okay. Try these on your own. Pause your video, please. So this one should have been pretty easy, but here, notice I didn't have a common factor in my x plus 4 and my y minus 4 because my variables were different. So there was nothing I could do. It cannot be factored. Okay, sometimes I'm going to have 4 terms in my polynomial, and this is going to get confusing because here I've got even numbers, so certainly I could pull out at least a 2 from here. I've also got x's in all 3 of these terms, but this last term isn't even, so I can't pull anything that's similar to those out, and I don't have an x to pull out of there either. So I'm going to try something different. I'm going to group these so that I can see if I'm able to pull anything else out. So I'm going to take these 2 right here and see what I can pull out that would be common to both. Well, I've got my 8x cubed, which is going to have a 4x squared in common with my 20x squared. When I take that out, I'm going to get 2x minus 5. Okay, so just to go back and prove this, 4x squared times 2x would give me my 8x cubed minus 20x squared. All right, and let's do that with my 6x minus 15. I've got a 3 that's common to both of these, and that would leave me with 2x minus 5. I've got a 2x minus 5 and a 2x minus 5. So I do have something that is factorable in this polynomial. So going back to the rule that we just learned, I can take out my 2x minus 5, and what I have left, remember there was a plus sign in between, I apologize, there's where that came from. Then I've got 4x squared, this guy right here, plus 3. Okay? So I can actually group these so that I can find common factors. So of course I'm going to do this again. I'm going to take these 2 terms, and I've got in common a 3a squared, leaving me 4 minus 3. Oh, 4a, sorry. 4a minus 3. And then this piece over here, I'm going to pull out a 5 times 4a minus 3. Wow, there was that 4a minus 3 that was in common. So I've got 4a minus 3, and I'm going to multiply that by 3a squared plus 5. All right. Definitely need to pause the video and practice this because this is not as easy as it seems, but once you get the hang of it, it is really easy. So pause your video. Okay, notice this time I was able to factor out a 4r over here, but there was nothing common with these 2 terms, so I had to leave it as is, but I do now have that r squared plus 6 on both of those. Remember that that missing piece is really a 1, so just wanted to check to make sure you got r squared plus 6 times 4r plus 1. If you got that on your own, awesome. Okay, factoring with opposites. So sometimes we may find that a binomial is is really just the opposite of the other, and we can help, and we can actually start factoring by, you'll see, but we'll be able to factor out a -1. So let's look at what that means. Here's an example of opposites. I've got x minus 5 here and 5 minus x. So my x is positive here, negative here, -5 here, and positive 5 here. So these are really just opposites. So, oops. So these are really just opposites. So what happens if I take the negative, a -1 out of this? If I take a -1 out, then this becomes negative, -5, and this becomes positive, positive x. Remember, I do have the commutative property. I'm just going to write this down, hopefully. You kind of remember what I'm talking about? The commutative property of addition. It tells me that I can move this around, so it's really -1 times x minus 5. And then look, I've got the x minus 5 I wanted by taking out that -1. So I've factored out the negative, even though it didn't appear that way, but by factoring out that negative, I now can have common factors. So let's look at an example of applying that. So I'm going to try grouping, and I've got this 5x squared that I can take out with an x minus 2. And then on this side, I've got 3 times 2 minus x. So I've got an x minus 2 over here and a 2 minus x over here. So I'm going to factor a -1 out of there. So if I take a -1 out, I'm going to have -1 times x minus 2. Well, remember that -1 is going to affect that 3, so this is now a -3. So I really have minus 3 times x minus 2. Okay, so what I have is x minus 2 times 5x squared minus 3, because I took that negative out, which was able to flip the signs on my x and my 2 so that I had common factors. And that's my final answer. Let's try another one together, because I know that looked a little bit complicated, but it's okay. Here I've got common factors of the first two of 5x squared, which leaves me with 3 minus 2x. And here I've got a 4 times x minus 3. 2x minus 3. I apologize. Okay, so I've got, again, positive 3, negative 2x, positive 2x. So I'm going to go ahead and, I like with the x first, so I'm going to take the negative out on this side. So I'm going to take a -1 out, which is going to give me a -3 plus 2x. I'm going to flip that around, so it's -1 times 2x minus 3. And then I have my common term, which I can pull out of 2x minus 3. And what's left was the 5x squared plus 4. Okay, and that is fully factored. So try these on your own, and if you're great at this, super. If not, we'll keep going over a couple more of these tomorrow in class. Okay, I'm unpausing the video here for a second because I want you to remember that I'm taking this negative out of both terms, and by taking the negative out, this became a positive 1 and a negative y. So when I pulled out that negative x, remember I can factor out a negative x, this became 1 minus y. So this one was a little more complicated, but hopefully it made some sense. All right, here is your video practice. Bring these to class tomorrow, and we will keep factoring polynomials.